How do we calculate the work of a constant force? So in order to calculate this work, we already knew that a force has a work if it's capable of moving an object. Then in this case, we know that we must have a force and we must have a displacement. Let's take an example. Here we do a force F, which move the object from the point A to the point B. So we can say the displacement is AB. This means that the force must exist in the formula of the work, and the displacement also must exist in the formula of the work. Now, should we multiply or divide in order to find the work of the force? As we notice that each time we increase the force, then in this case, for the same object, the displacement will increase, and thus the work of the force will increase. So in this case, we know that the force and the displacement are proportional to the work of the force. So this means that the work of the force is equal to the force multiplied by the displacement. But we know that the force is not a scalar quantity, it's a vector quantity. Same as the displacement. The displacement we are seeing from A to B, so it's a vector. So it's also a vector quantity, which means that the work of the force can be given by the scalar product of the force multiplied by the displacement. So we are multiplying two vectors, then in this case, we can write it in this form. So the work of the force is equal to the force multiplied by the value of the displacement multiplied by the cosine, the angle theta, which is the angle between the force and the displacement. So this will be the work done by a constant force. Let's do now a small application. So here is the formula, and we have to pay attention that the angle theta is not any angle, it's the angle between the force and the displacement. Example, if box is pulled with a force of 25 Newton, produce a displacement of 15 meters. So the angle is 30 degrees, and we have the frictional force is F equal 5 Newton. We have to determine the work of each of the forces applied to the box. So first we'll draw the forces applied to the box. So we have the weight, we have the normal reaction, and we also have the friction. So let's find the work of each of the forces. The work of the normal is equal to the normal multiplied by the displacement, which is moving from A to B. Let's suppose here, where AB is equal to 15 meters. So multiplied by AB, multiplied by cosine. Now the angle between the normal and the displacement is 90 degrees. So multiplied by cosine 90 degrees, which is equal to 0. So we obtain equal to 0, the answer. Now the work of the weight is equal to the weight multiplied by AB. We notice here that the weight also is making an angle of 90 degrees with the displacement. So cosine 90 degrees, which will be equal to 0. Now, work of the friction is equal to the friction multiplied by the displacement multiplied by cosine. Now the cosine here is the angle between the friction and the displacement. We notice that the displacement is from A to B, while the friction is opposite to the motion, which means that the angle here is equal to 180 degrees. So we'll have the force times AB multiplied by cosine 180, which is equal to -1. And then we have the friction is 5. AB is equal to 15, -1, which means it's -75 joules. We'll still have to find the work of the force here. We can call it the tension or F. So the work of this tension is equal to the tension multiplied by AB cosine. Now the angle made by the displacement and the force is 30 degrees, so it's cosine 30 degrees. So we'll have here as answer 25 multiplied by 15 and multiplied by cosine 30 degrees, which is equal to 324.75